All right, hello, math fans. All right, so these are more application problems. Remember, they're not word problems, they're application problems. Okay, so basically everything I've taught you guys so far about application problems we're going to be using here. Okay, so what I mean is you need to, number one, define your variable. Second is create an equation. Third is solve the equation. And fourth is give me the answer with units. Okay, every problem is worth 4 points. If you don't do all those different things, you are not going to get full credit for the problem. All right, so you have to have all your work here. Okay, and I'm not just being brutal because I want to be brutal here. I'm doing that because that's really in life. That's kind of what happens. Okay, you're given a job to do for your boss, and you got to define everything that's going on, and you got to set things up and solve and figure things out, and then you got to be able to give the board of directors your final results. Okay, and if you like don't give them, if you say how much is it going to cost, and you say it's going to cost 50, they're going to say 50 schmutzkis, 50 pennies, $50 billion. They're not going to have an idea what it means. So you got to give them the units. All right. So let's start out here. Number one, you've got $60 and your sister has $135. Man, your sister's got a lot of money. You decide to save $5 more a week. So that's a key word here. So let's kind of underline a couple things. $5 more a week while your sister decides to spend $10 a week. Okay, how long will it be before you have as much money as your sister? So when you have as much money as your sister, you want to know when you are going to have an equal amount of money. So that's an equal to sign. Okay. All right. So let's first of all, how long? There's the key word here. So x equals, and we're talking about weeks. So x equals weeks. Okay, that gives you 1 point. Sweet. All right. So you've got $60, and you're saving 5 more a week, or 5 more per week. And if you remember, it means multiplication. 5 more per week. So it's a couple things here. 60 is a fixed cost because you have $60 right now, right? And you're saving $5 more per week, so that's your variable cost. That's going to add up. So you're saving $5 per week. So this is you. Okay? Your sister's got $135. That's a fixed cost. She's got that much money. And she's spending $10 per week. That's important. So spending, that means you're losing that much. So it's minus 10x. And that's the setup for this, math fans. Okay? It's really not that bad, but you got to be careful. Make sure you got your positives when you're adding money and your negatives when you're subtracting money. Okay, so we're going to do a little work here. I'm going to add 10x to both sides. Okay, and subtract 60 from both sides. That cancels those out, and that cancels that out, and I get 15x is equal to 75. Divide by 15, x is equal to 5. Okay, so there you go. You got a point here, a point for setting it up correctly, a point for solving it, and of course our final answer is 5 weeks. That's how long it'll take. Okay, not bad. Okay, number two, you're designing a landscape for the front of your house. That's very exciting. You want to plant 5 bushes, which are each 3 feet wide. There are 2 feet between each end bush and the edge of the house. If the width of the house is 35 feet, how far apart should each bush be? Well, it's a lot of stuff in here, okay? But you take a piece at a time. First of all, how far apart? So x equals feet. It's pretty easy, okay? First of all, they ask you to draw a diagram. So let's do that. Here's your house. It's a very nice house. Oops, so much for that roof. Here, we're going to put a chimney on because lots of houses have chimneys. Okay, so here's your house, and it's you want to put 5 bushes, and they're each 3 feet wide. So 5 bushes, 1, 2, 3, 4, 5. And they're each 3 feet wide. So I'm going to put 3 in each one of these guys. Okay, and there are 2 feet between each end bush and the edge of the house. So there are 2 feet here and they're 2 feet here. Okay, and then it says how far. The width of the house is 35 feet. So this whole thing here is 35 feet. Okay, and then it says how far apart should each bush be? Well, if that's what you're looking for, and that's your variable, then you want to put it in here. X, 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 and X, right? Okay, so think about it. What do you have? Something's got to equal 35. Well, doesn't the distance between all those added together have to equal 35? So let's do that. Let's put it all together. Now I could put 2 plus 3 plus X plus 3 plus X plus 3 plus X plus 3 plus X plus 3 plus 2 equals 35 on there. But let's be a little smart here, okay? How many 2's do I have? I have 2 2's. So I'm going to actually show a little bit of work here. Here, I can move this down a little bit now. Okay. So I have 2 2's, right? That's that and that. I have 1, 2, 3, 4, 5 3's, so plus 5 3's. So that's 1, 2, 3, 4, 5. And how many X's do I have? 1, 2, 3, 4 X's, so plus 4X. What does that have to equal? 35. It's pretty easy. Just got to draw the picture and then you kind of add all the stuff up. All right. So let's combine. Let's do a little work here. We have 4 plus 15 plus 4x equals 35. Combine like terms, so we get 19 plus 4x equals 35. Subtract 19 from both sides. So then here I'm going to go back up here. 4x and 35 minus 19 is 16. And then divide by 4. So x is equal to 4. So again, that's going to give you most of the points, but your final answer is going to be 4 feet. That's how far apart the bushes should be. All right? And I'll tell you, this is an application that I have used in my life. Okay, when I was trying to plant bushes in the first home that I owned, I bought a whole bunch of bushes, and I had to mark all. I basically set up an algebra problem. I marked everything off because it's really bad just to start digging holes and planting bushes. Because what happens is you start to dig the holes, and then you get to the end, and it's going to crush a couple bushes together, and then it looks bad. So you have to use a little bit of math and figure things out to make everything look nice and even. All right, it's a great application that I personally used. Okay, number 3. It is approximately 4 miles between Schaumburg High School, boo, and Conant High School, yay. Bill leaves Schaumburg running at 3.5 miles per hour, and Christy leaves Conant running at 4.5 miles per hour. How long will it take for Bill and Christy to meet? Okay, so let's think about this. First of all, how long will it take them? So we're going to say x equals, since it's miles per hour, we're going to do hours. Right? X equals hours. And they're running towards each other. Okay, so let's actually let's make a little diagram here. Let's see. Bill is running at 3.5 miles per hour. And Christy is running at 4.5 miles per hour. Okay? And the distance between them is 4 miles. So it's, and there's a key word here, miles per hour. So what I always tell you guys when you see per, like, in all the other problems we've done, per, it's always multiplication. So this is going to be 3.5x, and it's going to be 4.5x. And that's going to equal 4 miles. Okay? Now here's the question. Is it addition or is it subtraction? They're running towards each other. A lot of times people like to think it's subtraction. Okay, but think about it. If they're running towards each other, aren't they running towards each other at a speed of 8 miles per hour? Don't you guys agree with that? If one's, it's almost like, and I hate to say it, but like you think of a head-on collision, where if somebody's driving at 50 miles per hour, and the other person is driving at 50 miles per hour, and they hit a head-on collision, what's the impact? Isn't it 100 miles per hour? Isn't that why head-on collisions are like so bad? It's the same idea. Bill's going 3.5 miles an hour, Chrissy's going at 4.5 miles per hour, and that means they're heading towards each other at a speed of 7 miles per hour. And so that's what we're doing, is we are adding their speeds together because they're going together that much faster at 7 miles per hour. Okay? And that's the setup for that problem. So it's 3.5 plus 4.5 is 8x equals 4. That's it. Divide by 8, x equals, reduce at 1/2. So it's 1/2 hour. That's the answer to that problem. Okay, number 4. Good old Mary. Mary's arranging her wedding album. Oh, it's so nice. Each page is 14 centimeters wide. She wants a border of 1 centimeter, and she wants to place 2 pictures on the page. Each picture is 5 centimeters wide. How much space is there between the 2 pictures? Okay, there we go. How much space is there? So x equals, we're talking centimeters, right? So centimeters between, and you can say centimeters between the two pictures. Got to draw a picture, guys. That's actually another point. If I ask you guys to draw a picture, especially anything like with bushes or pictures, you got to draw a picture. Okay. Anyway, this page is 14 centimeters wide, and she wants a border of 1 centimeter, and she wants 2 pictures. So this is the deal. Got 2 pictures. There we go. Very nice pictures. Okay, and she wants a border of 1 centimeter, so it's 1 centimeter here and 1 centimeter here. Each picture is 5 centimeters wide, so this is 5 and this is 5. And how much space is there between the 2 pictures? Guess what we're going to put there? That goes an x. So if the whole thing is 14 centimeters, just like we did before, it's 1 plus 5 plus x plus 5 plus 1. So I don't care how you write that. You can say there are 2 1s, and there are 2 5s, and there's 1 x, and that's got to equal 14. Okay, so we get 2 plus 10 plus x equals 14. So 12 plus x equals 14. Subtract 12, x equals 2. Okay, and then of course you are going to say 2 centimeters. All right. Sweet. Okay, number 5. Fremd High School. Good old strange Fremd. Fremd High School decreases by 10 students per year. And Palatine High School, Palatine's okay. Palatine increases by 45 students per year. In 1998, Fremd had a population of 3190 students, and Palatine had 2475 students. In how many years will the schools have the same number of students? There we go. In how many years? So x equals years. You could always use y also. That's fine. Anyway, when are they going to have the same number? So when are they going to be equal? That's the deal. Okay, so here's a key word, guys. It decreases by 10. So Fremd right now has 3,190 students, and it's decreasing by 10 per year. 10x. Palatine has 2475, and they are increasing, here's increasing, by 45 students per year. That's the setup for that one, okay? Not too bad. I'm going to add 10x to both sides because I like to keep positive values, and subtract 2475. So that cancels, and I get 715 on that side, and that cancels, and I get 55. Okay, and it's okay to use your calculator. Divide by 55, x comes out to be 13. So 13 years, they will have the same number of students. Okay, not bad. Okay, the next type of question here, converting it from English to math. That's basically what we're doing here. So it says write the verbal sentence as an equation, then solve the equation. Okay, so let's look at a couple words here. The sum. What does sum mean? Sum means add. Okay? The sum of 20 and 3 times a number. So, well, you could write, I don't care for this one, x equals a number. We'll do that. So the sum of 20 and 3 times a number is, remember, is always means equals, is 65. That's a setup for that one. That's pretty easy. So we're going to subtract 20. So 3x equals 45, divided by 3, x equals 15. Okay, there are no units for this one, so this one's a little bit easier. All right. Number 7. 3 more than 1/3 of a number. So 3 more, what more means add, right? That makes sense. 3 more than 1/3 a number is 25. That's a setup. Not bad. Subtract 3. So you get 1/3 x equals 22. Multiply both sides by 3/1 or 3. So x equals 66. Okay, not too bad. Okay, number 8. 10 less than 8 times a number. Now, this is a common mistake, math fans. Okay, so what I'd like you guys to do is write all your problems. If it's 10 less than that, think about it. It's 10 less than 8 times a number. So it's 8 times a number and 10 less than that. This is a common mistake. People do this. They say 10 minus 8x. That's wrong. Okay, you need to understand, that's not saying 10 less. It's like if I said you're 14 years old and what's 10 years less than your age, you don't say 10 minus 14 because you're going to get negative 4. Right? You say 14 minus 10. You subtract 10 less than that. Very important. Okay, so 8x minus 10 is 30. Okay, and then we just solve it. 8x equals 40, divide by 8, x equals 5. Okay, it's pretty easy. Number 9, 2 more, so 2 more than the quantity. Quantity means parentheses. Okay, that's important. M decreased by 3. So M, we give you the variable, decreased by 3. This isn't decrease, the same thing as subtraction. Is 8. Okay? So this one, there's nothing really to distribute here. So actually, I'm just going to go 2 plus M minus 3 equals 8. Combine like terms. So M minus 1 equals 8. Add 1 to both sides. And I get M equals 9. Okay, that's not bad. Okay, last one here. Number 10. 6 is 3/5 of the quantity 5 decreased by n. Now, is that this or this? If you're decreasing it by n, aren't you taking n away? Aren't you taking n away? Okay, if I said it was n decreased by 5, it would be this one. But it's decreasing by n. So it's 5 minus n. Okay? And let's distribute that. So 6 equals, well, we're multiplying 3/5 times 5 over 1. So that's going to give us 3. And then I'm just going to multiply that 3/5 times negative n minus 3/5 n. Okay, and solve it. So subtract 3 from both sides. So I'm going to rewrite it here, put the n on the one side. So negative 3/5 n is equal to 3. Okay, well, how do you solve for that? Well, that's pretty easy. You just multiply by its reciprocal. Negative 5/3, negative 5/3. Okay, and that cancels, and we get n equals, if I multiply that, the 3's cancel, 2, a 1, and a 1, and I get negative 5. All right, that was not too shabby. All right, so then anyway, that's all the application problems. And I'll tell you, when you guys are doing your homework, have this sheet handy and use it to help you do the application problems. Okay, because it's brutal when you do take all these notes and you go home and you're just like, yeah, I don't remember how to do it. And you come back to school and you're like, oh, yeah, I didn't get it. It's like you can get it because it's really not that bad as long as you have the nice little application sheet in front of you. All right, that's it, math fans. Have a nice day. Goodbye.